Hi class, when we work on our final design class diagram and sequence diagrams, some of the areas you need to work on is adding view layer and data access layer objects to your sequence diagram. And then for your design class diagram, you're going to make sure you follow some of these main ideas that we discussed this week. You don't have to include your view layer and data access layer objects in your design class diagram. It will make it very busy and we don't want to get there. But I want you to show a controller, if you could, show navigation visibility. The question we usually ask the students, do you like your code to look like puzzle pieces or Lego pieces? Or do you like your code to resemble pasta or ravioli? The questions that we ask all the time, and I ask you to pause here and think and then come back. Alright, you thought about it. Probably you think that Lego pieces, they have a better design. The pieces from one set could be easily reused with your projects from another set. So the pieces are reusable. If you think about those classes in your design class diagrams and the methods they provide, are they really like Lego pieces, or are they very specialized modules that are there to help you in your program only, and probably it's hard for you or for anyone else to reuse them again? And there is a trade-off. Sometimes you need those specialized objects for your programs, and sometimes you can think of reusability. So we don't tell you that there is a rule to follow, but we want you to keep these ideas in mind, that if there are areas like payment processing that could be reused in many of your other applications, make sure they're reusable. Spaghetti versus ravioli. Some of you personally prefer pasta. That's what we talk about in class. But ravioli is going to give you a better design of code. Why? Because those units are well defined. Every unit has sauce and has something in it. So if you were to share that with someone else, it's easy to share, and every piece is an individual and they have features that are all more or less the same. So they're easy to separate, easy to recognize, easy to share. Now we talked about ellipse as a shape, and we talked about model view controller. When we talked about ellipse, we talked about a geometrical shape that needs to know geometrical properties of itself and know how to calculate area and circumference, and that's all. So we didn't ask it to draw itself, we didn't ask it to print itself, so it does only and only one job. This is an example of a place where we actually applied some of these ideas. This is a module that's very easily reusable. Any geometrical application can use the same ellipse. Now, if you wanted to do it in a drawing application, you would have to add other modules, other objects. When we talked about model view controller, we talked about being easy to decouple. So this idea of spaghetti versus ravioli was used there in controller or handler. You are making it easier for yourself to separate layers from each other. You put something in between so they're not tangled. Cohesion is a general object-oriented principle. We say that an entity is cohesive if it performs a single well-defined task, and everything about it is essential to the performance of that task. So you have a staff here: check mail, send mail, email, validate, and print letter. Do you think that is a cohesive class? Think about it. The answer is no, because you're doing so many different things and you have so many reasons for changing. So you would change if your email platform changes, you would change if your printing mechanism changes, but this staff is cohesive. You have a salary and email address. You have setters and getters for that. Now, this one has only one purpose: to identify a staff on your team, and that's all it's concerned about. You are not worrying about email or the platform. You are not worrying about the printing mechanisms. You are just independent of those. And then we talk about coupling, the degree of dependence among components. Again, there are no rules here, but a loosely coupled design is preferred to a highly coupled design. Why? This is not good, because if you change this, you probably have to change this, that, then the other one. So you want to make your changes localized. So if you change something, only a few other areas to be modified. So you're trying to minimize the impact of a change. And obviously, this is an object-oriented software design. You cannot have a case with no dependencies. So this is another example. I have a scenario here, and I want you to give me the classes and their navigation visibility. So pause the video and draw your classes. You don't have to give me methods, but show navigation visibility. So if a ship can fire a bullet, it means that the ship can invoke the fire method inside the bullet. Go with that idea and draw your diagram, and then come back after you pause. So here how the scenario is shown visually. Ship calls the fire method in here. A bullet can hit, so it will invoke some methods in those two other objects. An asteroid can destroy a ship. A flying saucer can destroy the ship. So this is the idea that I can do something with you, or I can ask you to perform some services in the software for me, and that is how navigation visibility links are drawn. This is a relatively high coupling, or you could say it's in the middle. This one is a better design. So instead of everybody almost talking to everybody else, you have something in between. So instead of 5 links here, you have 4 links here. If something changes in the ship, the way it destroys itself, only this class will have to know and change accordingly. Flying saucer and asteroid, they don't have to know a thing about that change. Now this is good because you have abstracted or localized those changes in any of these 4 classes, but the problem is that now this class in between, it knows too much. So there is a trade-off. When you change your design, you probably are making something worse to make something better, and it should be you who makes a choice. Which one is preferable for this specific scenario, or this organization, or this application? There are different types of coupling, and it goes from just random coupling, just because you didn't know how to design an object-oriented software, and that's how some people did it in the earlier days when we transitioned from structural programming to object-oriented software development. And there is this functional coupling, is the one that we are practicing here. I call it functioning U. There are other types that discussion is beyond the scope of this class, but we want you to be aware of that idea, and this is a big topic in software engineering. What kind of coupling do we have? Are we working on the same data? Are we stamping the same piece of data? Are we having control over some processes? So this is a big discussion out there, but we just want to stay with the basics here in this class, and that's very useful. In fact, just a basic idea. You don't want to have so many interactions, just minimum number that can help you achieve your purpose. I will be back with solid principles. Thank you.